Hi, this is Dr. Chris Goebbels here from Square One, and today I'm going to go over how whiplash or motor vehicle collisions can cause an S-shaped curve in the spine. So, first of all, when we look at a normal healthy spine from the side, there should be a nice curve in the low back, a nice curve in the mid back, and then a nice curve in the neck. And when you have these normal curves, your spine is really strong and stable. What can happen in a car crash or when someone gets whiplash is it can cause a reversal or an S shape of the cervical spine. Now, to explain to you how this happens is we have the car that's hitting the other car, we call it the target car, and the car that's going to be hit is called the bullet car. And when one car hits another, all the momentum from the car that's hitting the other car gets transferred to the car being hit. And then that car immediately juts forward. And when that juts forward, that's going to push all the passengers forward, but the part that lags behind the longest is the neck. So imagine you're sitting in a car facing this way, and you get hit from behind, you get rear-ended. Your car is going to immediately jut forward, and this happens in a matter of fractions of seconds. Your seat is going to push your torso, this part of your spine, forward, and your head's going to lag behind. So this part's going to go forward, and your head's going to lag behind. And when that happens, and this juts forward, and this lags behind, that alone is going to cause an S shape or reversal of the spine. Then eventually this will snap back and then snap forward. So a person sitting in their car, they get hit from behind, the head comes back. Right now an S-shaped curve is being developed, then the head snaps back, and then all the way forward. Okay, so this is what I was talking about and how those S-shaped curves are formed. So over here on the left is what a normal cervical spine would look like. This in the middle is what happens when someone is hit. For example, this would be a rear end crash. The person's hit from the back. The chair is going to push the torso forward here. The head's going to lag behind. Because this is moving and this is staying still, that creates some shear force. Is going to cause some ligaments to be damaged, and that causes this S-shaped curve. Eventually, the head's going to snap all the way back, and then it's going to snap forward. But this is how some very specific injuries can happen. This is another example showing the same thing, and this kind of shows you the timeline. And this literally happens over 1.75 milliseconds, so 0.175 seconds, literally 0.1 and 0.2 or 3 at the uppermost is how long this takes. So this is actually faster than muscles can contract. So this happens so extremely fast, and most people aren't even aware these injuries can happen. So this is what it looks like as the end result. Now this is one that has been there for a while, but you can see the normal curve starts here, this reverses, and then here, that's an S-shaped curve right there. And this is something that we see a lot of times in our office, sometimes after the fact, but this would be an example of an S-shaped curve or a kyphotic or reversal of that curve. This is actually a patient that we saw in our office. Over here on the left was when he came in after he was in a motor vehicle crash and he had a whiplash injury. And you can see how he had, the green line is normal and the red is him, how he actually had a reversal of the cervical curve. And then over here on the right is him after treatment, and we're going to actually show how we go about correcting that in some subsequent videos. So if you've been in a car crash, or you're in a car crash, or you know someone who has, this is definitely one of the things you need to get checked for to see if you have. Now, in my subsequent videos, I'm going to go over the exact or specific kind of injuries that this can cause, and I'm also going to show you what we can actually do here at Square One to correct these reversals or S-shaped curves. So look for that in subsequent videos.